Dear students, I am Priyanka Dikshit, working as Assistant Professor at School of Pharmacy, Babu Banarsi Das University, Lucknow. Today I am going to present you on the topic Expectorants, Emetics and Antidotes. Starting with the definition of cough. What is cough? Cough is a protective reflux and its purpose being the expulsion of foreign particles from air passages. Expectorants, the drugs which are used to remove cough from the respiratory tract, are known as expectorants. Classification of expectorants. According to their mechanism of action, expectorants can be classified into two types: sedative expectorants and stimulant expectorants. Now, sedative expectorants. Sedative expectorants are the stomach irritants which are able to produce their effect through stimulation of gastric reflexes. Examples of sedative expectorants are ipecac, senega, Indian squill or bitters, ammonium chloride, potassium iodide, and sodium citrate. Mechanism of action of expectorants. Expectorants act by increasing the volume of the fluids that have to be expelled from the respiratory tract via coughing. They act by increasing the fluidity or by reducing the viscosity of the sputum. They act through the stimulation of mechano or chemoreceptors in the throat or respiratory passages as well as stretch receptors in the lungs. Stimulant expectorants. Stimulant expectorants act via stimulation of the secretory cells of the respiratory tract. Thereby more fluid in the respiratory tract and sputum gets diluted. Examples of stimulant expectorant are eucalyptus, lemon, and anise. Ammonium chloride. The formula for ammonium chloride is NH4Cl. Ammonium chloride is also known as salmiac or sal ammoniac. Ammonium chloride is an inorganic salt that is found in the urine. Ammonium chloride has a function in maintaining the pH of the body. Occurrence. Ammonium chloride is found in mineralogical formations and in this form it is known as salt ammoniac. It is also found in some volcanic vents as well as in ashes. Preparations of ammonium chloride. Ammonium chloride can be prepared by the Solvay process. Solvay process includes reaction of sodium chloride with two molecules of ammonia in the presence of CO2 and water to form ammonium chloride as well as sodium carbonate. It can also be prepared by reaction with hydrochloric acid or by treating with hydrogen chloride gas, where ammonia reacts with hydrochloric acid to form ammonium chloride. Also, ammonium chloride can be prepared by reacting or treating ammonium hydroxide with hydrochloric acid, where ammonium hydroxide reacts with hydrochloric acid to form ammonium chloride. Physical properties of ammonium chloride. Appearance. Ammonium chloride appears as a white crystalline solid. It is odorless in nature and it is having a cooling saline taste. The density of ammonium chloride is about 1.5274 gram per centimeter cube, whereas the melting point of ammonium chloride is about 338 degrees Celsius. Ammonium chloride is soluble in water, glycerol, as well as in alcohol. Reactions of ammonium chloride. Ammonium chloride sublimes upon heating and decomposes into ammonia and hydrogen chloride gas. This reaction involves decomposition of ammonium chloride into ammonia and hydrochloric acid. Ammonium chloride also reacts with a strong base like sodium hydroxide where it releases ammonia gas. Ammonium chloride, when treated with strong base like sodium hydroxide, leads to the formation of ammonia, sodium chloride as well as water. Ammonium chloride reacts with alkali metal carbonates at elevated temperatures, giving rise to ammonia as well as alkali metal chloride. This reaction involves treatment of ammonium chloride with sodium carbonate to form sodium chloride with the evolution of carbon dioxide and formation of water as well as ammonia. Assay of ammonium chloride. Principle. Ammonium chloride is assayed by indirect assay method. In the assay of ammonium chloride, this ammonium chloride sample is first dissolved in water and treated with previously neutralized formaldehyde solution. Methylamine is formed which further polymerizes to hexamine and results in the quantitative liberation of hydrochloric acid which is equivalent to ammonium chloride. The liberated hydrochloric acid is titrated with the standard solution of sodium hydroxide using phenolphthalein as an indicator. Endpoint is indicated by the appearance of a pale pink color. Procedure to perform the assay of ammonium chloride. First of all, standardization of 0.1 NaOH is performed. To perform it, weigh accurately 0.63 gram of oxalic acid into a 100 ml volumetric flask and make up the volume up to 100 ml with distilled water. Then, pipette out 20 ml of this solution and titrate it with 0.1 molar NaOH using phenolphthalein as an indicator. Continue the titration to get the concordant values. In order to perform the assay of ammonium chloride, accurately weigh 0.1 gram of ammonium chloride and dissolve it in 20 ml of water. Then, to this solution add a mixture of 5 ml of previously neutralized solution and 20 ml of water. After 2 minutes, the contents of the conical flask are titrated against 0.1 normal NaOH using phenolphthalein as an indicator. Endpoint is the appearance of permanent pale pink color. Each ml of 0.1 normal NaOH is equivalent to 0.005349 grams of ammonium chloride. Uses of ammonium chloride. Ammonium chloride is used as an expectorant in cough medicines. Its expectorant action is caused due to the irritation on the bronchial mucosa. Ammonium salts are an irritant to the gastric mucosa and they can act by inducing nausea and vomiting. Ammonium chloride is used as a systemic acidifying agent, so they can be used for the treatment of severe metabolic alkalosis. The main application of ammonium chloride is as a source of nitrogen in fertilizers. Ammonium chloride is also used as a flux in preparing metals to be tin-coated, galvanized, and soldered. Potassium iodide. The formula for potassium iodide is Ki. Preparation of potassium iodide. Potassium iodide is prepared by treating hot aqueous solution of potassium hydroxide with iodine in slight excess. This solution is further treated with activated charcoal which reduces iodate to iodine thereby utilizing the total iodine to get potassium iodide. The solution is then evaporated to dryness. Industrial preparation of potassium iodide. Industrially, potassium iodide may be obtained by the action of iodine on iron metal to form ferroferric iodide in the first step of the reaction. Further, ferroferric iodide gets decomposed with potassium carbonate to form potassium iodide, ferric oxide, and carbon dioxide. Properties of potassium iodide. Potassium iodide occurs as colorless or white cubic crystals or granules. Potassium iodide is odorless in nature and it is having a bitter and saline taste. When exposed to photochemical decomposition, potassium iodide becomes yellowish in color by liberating the traces of free iodine. Density of potassium iodide is 3.13 gram per centimeter cube and it melts at 681 degrees Celsius, whereas it vaporizes at 1330 degrees Celsius. Potassium iodide is highly soluble in water. About 140 gram of potassium iodide is soluble in 100 ml of water at 20 degrees Celsius temperature. Aqueous solution of potassium iodide can readily dissolve iodine. Potassium iodide is sparingly soluble in ethanol, acetone, and slightly soluble in ether and ammonia. About 2 grams of potassium iodide is soluble in 100 ml of ethanol at 25 degrees Celsius temperature. Uses of potassium iodide. It is used as a source of iodine in thyroid hormone deficiency. It is used as a table salt. Potassium iodide is also used as an expectorant. Potassium iodide can be used as a saline diuretic. Potassium iodide also possesses antifungal properties. Potassium iodide is also used in chromatographic analysis. Potassium iodide is used as an co-solvent and also in quenching of fluorescence. Emetics. Emetics are the drugs which give rise to forced regurgitation. These are the drugs which act by expelling the contents of the stomach through the oral cavity, and they are used in the treatment of poisoning. Types of emetics. Emetics can be categorized into two types. First one is locally acting emetics. Locally acting emetics act by local irritation on the gastric mucosa. Examples of locally acting emetics are ammonium bicarbonate and ipecacuanha. Centrally acting emetics. Centrally acting emetics act directly on the chemoreceptor trigger zone or CTZ, which is located in the floor of the fourth ventricle in the medulla part of the brain. Examples of centrally acting emetics are apomorphine and morphine. Uses of emetics. Emetics act by producing a reflex action through which toxic substances or poisons get expelled out of the body. They are added in the cough preparations. Emetics are used to stimulate flow of the respiratory tract secretions as well. Natural emetics. Examples of natural emetics are intake of common salt with warm water, intake of grounded mustard seeds with warm water, or taking a strong coffee after a narcotic poison. When emetics should not be used. Emetics should not be used in case of corrosive poisoning or in case of acid or alkaline poisoning. Emetics should not be used in case of CNS stimulant poisoning, and it should not be used to unconscious patients. Copper sulfate or blue vitriol. The formula for copper sulfate is CuSO4.5H2O. Preparation of copper sulfate. In the laboratory, copper sulfate is prepared by dissolving cupric oxide or cupric hydroxide or cupric carbonate in dilute sulfuric acid as shown in the reactions below to form copper sulfate. Properties. Physical properties of copper sulfate. The anhydrous salt of copper sulfate is colorless in nature, whereas the hydrated salt is blue in color. Copper sulfate is readily dissolved in water, whereas it is insoluble in alcohol. Chemical properties of copper sulfate. Action of heat. Copper sulfate decomposes at 720 degrees Celsius to give cupric oxide and sulfur trioxide. Action of ammonium hydroxide. Copper sulfate, when treated with ammonium hydroxide, forms a deep blue colored complex. Action with Ki. When Ki is added to a solution of copper sulfate, a white precipitate of cuprous iodide is formed. Action with KCN. A yellow precipitate of cupric cyanide is formed with KCN, which further decomposes to give cyanogen gas. The reaction involves treatment of copper sulfate with two molecules of potassium cyanide to form cyanogen gas. Action of alkalis. With alkalis, a pale blue precipitate of copper hydroxide is formed. Action with H2S. Copper sulfate reacts with hydrogen sulfide to give black precipitate of copper sulfide. Uses of copper sulfate. Copper sulfate is used as a germicide and insecticide in agriculture. A mixture of copper sulfate along with lime is commonly known as Bordeaux mixture, and it is used as a fungicide. It is used in electroplating, calico printing, as well as in electrical batteries. Potassium sodium tartrate. Chemical formula for potassium sodium tartrate is KNaC4H4O6.4H2O. Potassium sodium tartrate tetrahydrate is also known as Rockley's salt or double salt of tartric acid. Potassium sodium tartrate is prepared in two steps. In the first step, two molecules of sodium bicarbonate reacts to form sodium carbonate. Further, in the second step of the reaction, potassium bitartrate or cream of tartar reacts with sodium carbonate formed in the first step to generate sodium potassium tartrate or Rockley's salt. Properties. It occurs as a colorless to white crystalline powder with a cool and saline taste. It is soluble in water and insoluble in ethanol. It has a pH value of 6.5 to 8.5. It has a large seismometric effect which makes it widely useful in sensitive vibrational and acoustic devices. It slightly effloresces in warm air. At 100 degrees Celsius, it loses 3 molecules of water and becomes anhydrous, whereas at 130 to 140 degrees Celsius and at 220 degrees Celsius it begins to decompose and loses its identity. Uses: it is used as a laxative. It is used in the silvering of mirrors. It is one of the ingredients of failing solution. It is used in the electroplating process. It is used in cigarette paper as well. It is used to break up the emulsions. Antidotes. According to World Health Organization, antidotes can be defined as the therapeutic substance used to counteract the toxic actions of a specified xenobiotic. Supportive therapy plus correct antidote can lead to patient survival. Antidotes reduce the overall burden of health service in managing of poisoning cases. Need for antidotes. The poison is required to be expelled out of the body as soon as possible. Emesis or gastric lavage or other procedures may not completely help to remove the poison from the body. If the poison is administered other than the route of ingestion, it needs to be removed immediately. When the poison may already be absorbed, it becomes important to make use of antidotes to discharge the poison out of the body. Classification of antidotes. Antidotes can be broadly classified according to their mode of action and according to their site of action. According to their mode of action, antidotes may be classified into three types: physical antidotes, chemical antidotes, physiological or pharmacological antidotes. According to their site of action, antidotes interacts with the poison to form non-toxic complex that can be excreted out. Antidotes accelerates the detoxification of the poison. Antidotes decreases the rate of conversion of poison into a toxic metabolite. Antidotes compete with the poison for certain receptors. Antidotes block the receptor through which the toxic effect of the poison is mediated. Antidote bypass the effect of poison. Antidote form antibodies against the poison. Mechanical antidote or physical antidote. Mechanical or physical antidotes act by preventing the absorption of poison in the body. They act via neutralizing the poison. They act by expelling out the poison by emesis or vomiting or elimination of the poison through the urine. Mechanical antidote exerts their effect by interfering with the physical properties of the poison. Example of mechanical antidote is activated charcoal, which works by absorbing poison prior to its absorption in the body. Physiological or pharmacological antidote. Physiological or pharmacological antidotes act by producing the effect opposite to that of poison. That is, these agents act on the principle of antagonism. They act by counteracting the effect of the poison physiologically by converting it into some another form. Sodium nitrite is an example of physiological or pharmacological antidote which acts via converting hemoglobin into methemoglobin for binding cyanide. Most of the antidotes are only partial antagonists in their action. Chemical antidote. Chemical antidotes act by combining with the poison and changing the chemical nature of poison. Example of chemical antidote is sodium thiosulfate, which acts via converting the systemically absorbed toxic cyanide into non-toxic thiocyanate. Universal antidote: if the nature of the administered poison is not known and it is suspected that two or more poisons have been taken, then universal antidotes are to be used or administered. They are simply the mixture or combination of physical and chemical antidotes. Example of universal antidote is activated charcoal, or 2 parts of activated charcoal plus 1 part of tannic acid along with 1 part of magnesium oxide, and this combination is generally less effective than activated charcoal alone as an oral antidote. Activated charcoal: common charcoal is made from coal, wool, coconut shell, or petroleum. Activated charcoal is made from common charcoal by heating in the presence of a gas. This causes charcoal to develop lots of internal pores, and these pores act to absorb toxins. Activated charcoal is also known as activated carbon, activated coal, carboactivators, or active charcoal. Preparation of active charcoal. There are two methods for the preparation of activated charcoal. First one is physical method or physical methods. Physical methods includes carbonization and oxidation. Carbonization. For carbonization reaction, material with a carbon content is pyrolyzed at temperatures in the range of 600 to 900 degrees Celsius in the presence of oxygen in an inert atmosphere with the gases like argon or nitrogen to form activated charcoal. Next method, which comes under physical method for the preparation of activated charcoal, includes oxidation reaction. Under oxidation method, carbonized material is exposed to oxidizing atmosphere or oxygen at temperatures above 250 degrees Celsius and usually in the temperature range of 600 to 1200 degrees Celsius to form activated charcoal. Chemical method for the preparation of activated charcoal. Chemical method for the preparation of activated charcoal involves the treatment of raw material with certain chemicals prior to carbonization. These chemicals include strong acids, bases, or salts, such as phosphoric acid, potassium hydroxide, sodium hydroxide, calcium chloride, and zinc chloride. The raw material is further activated at lower temperatures, generally at a temperature of 450 to 900 degrees Celsius. Chemical method is mainly preferred over physical method because lower temperatures and shorter times are needed for activating the material. Properties: it occurs as a fine black powder. It is odorless, tasteless powder having a smooth touch. It is free from gritty particles. It is a form of carbon processed to have small pores. These pores increases the surface area available for the adsorption or chemical reaction. Uses: activated charcoal adsorbs drugs such as alkaloids, sedatives, or hypnotics, or we can say activated charcoal is used in the poisoning of alkaloids, sedatives, and hypnotic drugs. It is also used in case of opium cyanide and barbiturate poisoning. It is also used in case of poisoning that is caused due to the absorption of gases, poisoning caused Due to the excessive gases such as carbon monoxide, carbon dioxide, and nitrous oxide, the activated charcoal will act by absorbing the gases to overcome their toxic effect. It is used in case of diarrhea to absorb toxins, bacteria, and viruses. Activated charcoal is used in the ratio of 5:1 or in the ratio of 10:1. Sodium thiosulfate. The chemical formula for sodium thiosulfate is Na2S2O3.5H2O. Preparation of sodium thiosulfate. Preparation of sodium thiosulfate salt involves heating of aqueous sodium sulfite solution along with sulfur. The production of sodium thiosulfate can be further accomplished by boiling aqueous NaOH or sodium hydroxide with sulfur. This reaction involves treatment of 6 molecules of sodium hydroxide with 4 molecules of sulfur to form sodium thiosulfate, sodium sulfide, and water. Properties of sodium thiosulfate. Physical properties of sodium thiosulfate. Sodium thiosulfate occurs as a white crystalline solid. It is odorless in nature. The density of sodium thiosulfate corresponds to 1.66 grams per cubic centimeters. The pentahydrate form of this salt has a melting point of 321.4 Kelvin and a boiling point of 373 Kelvin. The solubility of sodium thiosulfate in water is 70.1 gram per 100 ml at 20 degrees Celsius and 231 gram per 100 ml at 100 degrees Celsius. The crystal structure of sodium thiosulfate is monoclinic. Chemical properties of sodium thiosulfate. Sodium thiosulfate salt dissociates in water and other polar solvents to yield sodium and thiosulfate ions. The sodium thiosulfate salt decomposes at higher temperatures to yield sodium sulfate and sodium polysulfide. When exposed to dilute acids, sodium thiosulfate undergoes a decomposition reaction to yield sulfur with sulfur dioxide. The alkylation of sodium thiosulfate yields S-alkyl thiosulfates, and these compounds are commonly referred to as Bunty salts. Uses of sodium thiosulfate. Sodium thiosulfate is used in cyanide poisoning. It is used to treat dermatophytosis or ringworm infection. Sodium thiosulfate reacts with iodine to reduce it to the iodide ion while it is oxidized to tetrathionate ion. Sodium thiosulfate is used as photographic fixers due to its ability or due to the ability of the thiosulfate ions to react with silver halides that are making up photographic emulsions. Ammonium thiosulfate and sodium thiosulfate make up lixiviants or liquid mediums used in hydrometallurgy, which are used in the extraction of gold from its ores. In order to reduce the chlorine levels in water bodies, sodium thiosulfate is used in the dechlorination process. Sodium nitrite. The chemical formula for sodium nitrite is NaNO2. Preparation of sodium nitrite. Sodium nitrite is prepared by reacting sodium hydroxide with nitric oxide and nitrogen dioxide to form sodium nitrite and water. Sodium nitrite may also be prepared by reacting sodium carbonate with nitrogen oxide and oxygen to form sodium nitrite and carbon dioxide. Physical properties of sodium nitrite. Sodium nitrite occurs as a white crystalline solid. The density of sodium nitrite is 2.26 gram per ml. Melting point of sodium nitrite is 308 degrees Celsius. Sodium nitrite exists as a trigonal or rhombohedral crystal. Chemical properties of sodium nitrite. First one is reaction of sodium nitrite with ammonium chloride. On heating ammonium chloride with sodium nitrite, initially ammonium nitrite is formed along with sodium chloride. Then this ammonium nitrite decomposes further into nitrogen and water. Then reaction with hydrochloric acid. Sodium nitrite reacts with hydrochloric acid under boiling conditions to produce sodium nitrate, sodium chloride, nitric oxide, and water. Sodium nitrite reacts with sulfuric acid to form sodium sulfate, nitrogen dioxide, nitric oxide, and water. Uses of sodium nitrite. Sodium nitrite is used as a preservative. It is used as a coloring agent. It is used as a reagent in techniques involving analytical chemistry. Sodium nitrite is used as a corrosion inhibitor, as a food additive, as a hog poison, and as an antidote in case of cyanide poisoning, where it is used in combination with sodium thiosulfate. Sodium nitrite is also used for the production of various dyes as well as fertilizers. It is used for bleaching fibers and printing textile fabrics. Sodium nitrite is also used as a laxative to treat constipation. It is used as a bronchodilator and vasodilator in the medical field. So that's all about expectorants, emetics, and antidotes. Thank you.